All right, our second multiplication proof with even and odds we're going to do is we're going to say, is it true that any even number multiplied by an odd number is going to give you an even number? Let's think of some examples, right? If you can immediately think of a counterexample, you know this is false. But let's think of an example, right? Even, so let's do 2 times 3, that's 6, that's even. 4 times 7, that's going to be 28, yep, that's even. And just to be safe, 1 times 4, that's 4, that's even. Or 1 times 10, that's even, right? So this is probably true, so let's try and prove it, right? See if we get stuck, maybe it's false, but I think we'll be fine here. So let's write this out as a mathematical statement. Usually this is what you're just going to be given in general anyway, but we're saying for any even and any odd, so this is a for all, proof of for all statement. So we're saying for all, and let's call evens A and odds B, okay? So for all A and B that are integers, given A is even and B is odd, A times B is even. Okay, sometimes it's a sentence, sometimes it's a question, it doesn't matter. You should be able to see what your P and Q are, right? This is basically our if, this given part, if A is even and B is odd. And then there's an implied then here with the comma, then A times B is even. So we know automatically that in our proof, this is our P and this is our Q. We suppose this to try and show that Q is true. Okay, great. What else do we need to know from this question? Well, we automatically see that we need to know what an odd number is, what an even number is, in order to prove that A times B is even. Okay, so let's remind ourselves what those definitions are. Even is x, an integer x, such that x is equal to 2k, where k is also an integer. Okay, odd is going to be x, that's also an integer, such that x is equal to 2k plus 1 for some k that's an integer. Great. If you want to test these, definitions, plug in some even and odd numbers, see if they truly are even and odd, right? Because the way you'd show that is you'd say plug in some even x and show that k would be an integer, or plug in some odd x and show it's not an even integer, and vice versa for the odd. Okay, now we can start writing our proof. So what do we do when we see a for all statement? We immediately think of let. That's the first word that should come out of your mouth before you even think is let. Let. What are we letting? We're letting A and B be integers. Let A, comma B be in the set of integers. Great. We've done that. Also, we want to suppose P, right? We want to say, okay, let's take any A and B integers, and let's say A and B are any even and odd numbers. So we're going to say, and A is even, and B is odd. Great. We started our first sentence. Awesome. So next thing we want to do is more rigorously prove what we mean by even and odd, so we can use these to get to even, right? So we say, suppose, or actually, no, I've changed my mind. Let's say then. Then A is equal to 2m and B is equal to 2n plus 1 for some m, n in the integers. You want to define any variables you create so the reader knows what they are. They don't just come out of nowhere. It's like when you're reading a book and they all of a sudden start saying someone's name that you've never met before and they've never talked about. And you're like, who is this, right? Same kind of reasoning here. Great. Now we want to really test if our Q is true. So we're going to look at this and see if from this we can get to some form that looks like x is equal to 2k, right? So let's begin. We'll say next. a times b is 2m, I'll put a bracket around it, multiplied by 2n plus 1. Okay, can we see this at the moment? You actually can. Can you? No, you can't. I was going to say, you might want to say, oh, well, isn't this just equal to 2m multiplied by 2n plus 1? And there we go, we have 2 times something. Oh, actually, you can. I'm sorry. Here you can just say, hey, take the 2 out, and you have 2 times some integer, right? M times 2n plus 1 is just going to be some integer. And this totally works. You can use this absolute reasoning if you would like to. And this is, I think, a creative form of reasoning. I wasn't even sure just now that it would work. But you can definitely say this. You can just take the 2 out and say, hey, m times 2n plus 1 is an integer. So you have something in the form of, this would be our k, that's our 2, equal to a times b is going to be our x, right? That's what that is. So we have x equals 2 times k. Great. We've shown that it's even and you can write your conclusion. But I'm going to show you a second way you could have shown this, because oftentimes there's more than one way, and I think this way isn't better. I think this was a really smart and creative way of doing it, but you might not always be able to do it for harder examples. So, and it's always good to practice your pre-calculus elementary school math. So instead we're going to expand this, right? We're going to say this is equal to 4 times mn plus 2m, right? Okay, awesome. What can we do? We can factor out a 2 to get the 2 we're looking for here. So this is going to be equal to 2 times mn plus, oh, my bad, 2 times 2mn plus m. Okay, great. And it's the exact same logic we saw before, except this time, instead of having m times 2n plus 1 as an integer, that's not what we're looking at here. Instead, here we have 2mn plus m is going to be our integer. So what do I mean by this? Obviously, what I'm saying here is what's in the brackets is going to be our k, our 2 is here. All this is one big long equal sign. Our a times b is just going to be an x, right? That's going to be what this is. X is equal to 2k. That's our k, that's our x. We got something that looks like it's in the form of an even number by our definition of an even number. So now we just want to write our concluding statement. We want to say, since 2mn plus m is an integer, and a times b is equal to 2mn times m, then by definition of even, a times b is even. Great, we've proved it. Again, like the other videos I've made, you can definitely say 2mn plus m is like g, right? Or k. You can literally just write after this, let 2mn plus m equal k, and then you can say, hey, that's an even number, but why add this extra step? You really don't need to do that. So there we go. We've just shown that any even and odd numbers multiplied is going to be even.